MacMaths, let's do some maths today. Okay guys, welcome back. Today we're going to be looking at solving harder AS trigonometry equations, and I'm going to run through that with you. This will help you with exercise 10E. I'm going to do it in two parts, so I'm going to do a part 2 because exercise 10F has the quadratic sides and other aspects which I'm going to look at in another video. But I'm just going to concentrate today mainly on the transformations and how they affect it when we solve trig equations. I'm also going to do a supplement to this as well, so I'll do another little video where I'll go through some of the key questions within exercise 10E. So you should be able to do the questions from what I show you today or this morning, but to help you with the exercise I'll go through some of those questions as well, but that will be in a supplementary video. Okay, so let's have a look at the transformations then. I just wanted to remind you of the work when we've been transforming graphs. So I've chosen y equals sine theta here. And I just wanted to go through the transformation of that. So this is our y equals f of x. If we times it by a number, a I've chosen here, so we put a 2 there. Remember that's a stretch in the y-axis. But if we actually put a number here in front of the x or the theta in this case, if you remember, that's also a stretch, but it does that stretch the opposite of what you think. So if we put a 2 in here, it actually squashes it. So this one here, where this wave has been squashed into 180 degrees, as it is here, this is the graph of y equals sine 2 theta, and that's going to be relevant to what we're going to do today. The y stretch doesn't affect the solving of it, but the stretch, the squash does. So y equals sine 2 theta would look like this, and of course it continues, you know, in both directions now, but twice as dense, if you like, within a complete cycle of 0 to 360 degrees. And likewise, you can see that this one has had the opposite. It's been stretched out. It's this one, but it's been stretched out to 720. I've missed the 720 off there, but you can see only half of it now fits in. And of course, this is y equals sine of a half theta. So that half has done the opposite of what we think. Instead of squashing it by a half, it's actually stretched it by 2. Okay? And remember, the sine of 3 theta, it would, again, you know, we'd have a complete wave within 120 degrees, another one by 240, and a third one by 360, and so on and so on and so on. And that's going to be relevant to what we're going to be doing today. Also remind, we're going to be looking at what happens when we add a number to the end of a function. It moves it up or down. It's not going to affect us today, but this one is. We're going to be looking at this one. And again, when we add it to the x, like when we do the stretch to the x, it's a translation. It moves it left or right, and it does it to the opposite of what we think. So a plus a moves it back minus a, and a minus a moves it plus a that way. Okay, so we're going to be looking at those today. And we don't really have to think about this too much when we're solving them, but I just wanted to remind you of that so you can start to connect these things up in your brain. Okay, in your little squirrel brains. Right, okay, so let's have a look at some of those transformations then. So I'm going to start with pick a colour. Do you know what, I've not used brown, so I'm going to use brown and pink I think today. So we're going to have a look. I'm going to start off with, so these are my examples for you. I'm going to do solving sine of 2 theta is equal to 0. I'm going to keep it sort of simple so I can work out the numbers easy. And I'm going to do that. I'm going to give a range that I want to solve. You'll always see this. And I'm going to put theta between 0 and 360 degrees. Okay. So the sine of 2 theta, remember, if you remember, that has done that squash. So between 0 and 360, we're going to get twice as many values. Because the wave happens twice as many times. So when I see 2 theta, you know, I work out the values that are double this range. So I do from 0 to 720. You'll see what I mean in a second, okay? So first of all, sine of 2 theta is equal to 0. What do? We inverse sine both sides, don't we? And when we inverse sine, okay, so when we do that on our calculator, and we inverse sine 0, well, remember, I don't go to the cast wheel for this. I look at my sine graph. Where does sine equal 0? Well, this is the 0 line, and it happens at 0 degrees. Go along 180 degrees, and I go along 360 degrees, and you keep going, and I'm going to go, you know, 0 to 360, and I'm going to do another wave. So I'm going to carry on here. You can see my hand. And I'm going to go and I'm going to add another 180, so 540 it would be, and 720. So that is 2 complete waves, okay? And the reason that I did that is because once I've got all of those values, which are the inverse sine of 0, and I get those first, the last thing I do is divide by 2, okay? As we would do with a normal equation, you know, that was 2x equals something, we just divide by 2 to get x equals. So we're going to divide all of these by 2. So when we divide all of these by 2, we get our values for theta. And from that sort of graph that we had, okay, you know, we're going to get these sort of 4 values, you know, looking at it, you know, on the actual graph. Okay, so let's divide them all by 2. We get 0, we get obviously 90 degrees, we get 180 degrees, we get 270 degrees, and we get 360 degrees. Okay, so this is all of the values for theta that lie in the range between 0 and 360 when we've got the equation sine 2 theta is equal to 0. Now I just want to draw your attention to something here. It is time now, when you're doing exam questions, to start looking carefully at the question. And this, I did this one deliberately. If you look at the range that it's asking you for now, all the other ones has been, you know, greater or equal to, or less or and equal to. But this time I've put less than 360 degrees. So that's it's easily missed when you're doing an exam question, but look carefully at the range. So this means these are all values that would solve this, but the 360 is not in the range that it's asking for, because it's asking for less than 360. So if we include that on an exam question, we will lose a mark, and they have done this on purpose to see whether you're looking and paying attention to the range that they're giving. So look very carefully at the greater, you know, and less than signs, and make sure that you include all values within that range and don't include values that are not in that range. You will lose marks otherwise. Okay, so actually this has 0, 90, 180 and 270 to it. Okay, let's have a look at another one. This time I'm going to go, so EG2, I'm going to go sine 2 theta, no I'm not, I'm going to go sine of theta minus 40 degrees, okay, and I'm going to put that equal to a half, so I'm going to solve this one. Okay, I did say I was going to go with pink, and I've carried on with brown. I got so excited, but I'll go with pink with this one. So sine theta minus 40 degrees is equal to a half. I'm going to change the range now. So I'll change the range and I'll go, let's go 180, and yeah, let's go minus 180. Makes it more exciting, doesn't it? Okay, so we're going around the cast wheel the other way. Okay, so the first thing that we do with this one, we got this equation, we've got our range, we're going to solve. We haven't got any numbers in front of sine now, so it's just sine. We've got down to this, we've probably done some other stuff, we've got down to sine of an angle. This is our angle here, okay, and we inverse sine now, and when we inverse sine we get theta minus 40, and when we inverse sine a half, okay, we get 30 degrees. I'm going to put that on my cast wheel there. It's positive, so I do want it in that region, So we'll get 30 degrees. You can see what we're going to do next. We're going to add 40. But we're not going to do that yet, and you've got to be really careful not to do that, because if you add 40 to that to get 70 at this point, the temptation then is to put 70 into your cast wheel and work out the equivalent for 70, and that would be the wrong thing to do. Okay, so what we're going to do is, before we add 40, we're going to find all the other values, because it's not just 30 degrees, is it? We're going to find those first. Okay, so I'm going to go with 30 back. We've gone 30 in, so we go 30 back here. This is the sine region, so we know that 150 degrees is also within that range. So look at the range, we want up to 180, so we don't want to go round a second wheel. But minus 180, I've drawn my little blue. If I go back, okay, you can see here, I go back to minus 90. This is the cos region, so that's not going to work, okay? And let's go back into where sine is positive. So I've got to go minus 180 here, and then another 30 in is minus 210. Now I'm tempted not to put that in, okay, because it's going outside of my range, but I am going to put it in. I'm going to go minus 210 is also a value. It is. It's just not in our range at the moment. And if I carried on going round here, okay, I'd get to minus 330 degrees, okay. Alright, so I've done a full loop to 360 and got those two values for positive a half. And for positive a half, if I go negative, go around the opposite way, the first value I come to within the sine region is at minus 210. So that means the sine of minus 210 would give us a half, a positive a half, and the sine of minus 330, I'll put it in there, if I'm going around the other way, would give us positive a half, because it's in that positive region for sine, okay? But now look, now I've got to add the 40, so I'll only do that's the last thing that I do to get my theta, okay? So I add 40 to all of these, and when I add 40 to all of these, I'm going to get 70 degrees, I'm going to get 190 degrees, I'm going to get minus 170 degrees, and I'm going to get minus 290 degrees, okay? So now you can see that that is a value. That one there has now fallen out of my range. There's my range, okay, and we only want to go up, so we need to cross that one out. Minus 170 was outside of the range, but it's now fallen inside of the range, so it was wise to include that, and that one, you know, is still outside of the range, isn't it? Okay, so this one and this one are the two that I want for theta. Okay, so theta is equal to 70 degrees and theta is equal to minus 170. Those are the two values in here that when you put them into there would give you the sine of a half between these ranges here. And those ones we must make sure that we cross those out on our exam paper or get rid of those values. Okay, so only these two are seen as our final answer. Okay. Now we've looked at a stretch and a translation. Of course, you know, they're gonna step it up and combine the two. So what I think I'll do is I'll just rub that top one out. I'll leave that one in for a minute, and I'll say what happens if they combine the two things. Okay, so I'll look at EG3, but I'll just slot it in here because there's a massive overlap. Okay, so say I went an EG3 and said solve sine of 2 theta minus 40 is equal, I'll stick with my half because we've already worked out the values for that, and we'll do again between theta is between 180, so I can just keep the same values, and minus 180. Okay, so say we had this one. So it's combining example 1, the sine 2 theta, combining example 2, the minus 30, same sort of question. I've put a half for this one. So if we're doing it for this one, obviously inverse sine, and we know what's going to happen here. We're going to go 2 theta minus 40 when we inverse sine, and we've got those. We're inverse sine and a half, so oops, slip to that. Let's go with orange. Let's go with orange. I'm going to go 30, 150 minus 210 minus 330. Okay, so I'm going to go with those. Am I going to go with those? Yes, I am. Okay, and so then when I, the first thing I'm going to do is I'm going to add 40 to those, aren't I? So I'm going to go to, so that will leave me with 2 theta, and that will give me sort of 70, and what am I doing? Add, so 190 minus 170 and minus 290 degrees. So that is going to give me 2 theta, so I've added 40 to all of those. We had that line there, didn't we? And then that was adding the 40, gave us that one, and then we divide by 2 at the end. So you can see what we're doing. So you may get that question, and we divide by 2 and we get 35 degrees, 95 degrees, minus 85 degrees there, and half of that is minus 145. Ooh, I did that very quickly, didn't I? Okay, so I've halved all of those now, and I've got those values, and actually if you look at all of those, they all fall within that range now, and that's you know, testament to the fact that that curve has been, that wave, sorry, has been squashed, and we've got more values. So all of those now are within the ranges of minus 180 to plus 180. Okay, so there we go. We looked at 2 theta, we looked at a translation, and we combined the two. I hope that made sense. Okay, you can see that this one was almost the same as that one, that's why I left it up. Okay, before I stop this video, I just want to remind you of a couple of other things. Really, oh, that's my phone, got my phone here. That's probably another subscriber to my channel. I just want to remind you of squared. Okay, so we looked at the previous lesson of what happens when we get one of these ratios, sine, cos or tan squared. Can I just remind you what we do? So I'll do this one between 0 and 360. I won't try and catch you out here. I also want to remind you of solving ones like, I'll do another example. Let's think, what should I do? So 3 sine theta is equal to 2 cos theta. We're going to come across those, so we'll look at that one as well. So let's have a look at these two then. First of all, this one, just to remind you very, very quickly now, I'm going to do this, square root both sides, don't we, to get tan theta. But when we square root, we've got to remember to get the plus or minus, okay? When we do the plus or minus of this, okay, remember we only ever put the pluses, or I only ever put the pluses in your calculator, and watch how slick this is. Now I've really upped my game. Oh, wow. Okay, look. Oh yeah, clip it in there. Okay, so I've done a cast wheel ready to save time. So if we look at this one, for plus 2, if you inverse root 2, the tan of root 2, you get 54.7 degrees. Okay, that's the inverse tan. So if I put it on here, 54.7, there it is. Okay, so that's turning 54.7. If another subscriber, if we turn where tan is positive, so we want the two values of plus root 2, it's 57 into this region here, 54.7, sorry, into this region here, and that would be 234.7 degrees. So we've got those two at 234.7 as well as the 54.7. But for the minus root 2, it's that angle, but it's in the two sort of negative regions into there and into there. Okay, so we've got to do 180 minus 54.7 and 360 minus 54.7, and that gives us the two values of an extra 2 of 125.3 degrees. And yes, you probably guess I got these written down because I worked them out just a minute ago before I started the video, and 305. So 125.3 and 305.3 degrees, turning back into those two regions. I tend to like them. If I was doing this on my board in class where I'm slowing down, I'm doing it a little bit slower for the students in front of me. As you know, I like to put these in order. So I list them. Theta is 54.7, 125.3, 234.7 and 305.3. And those are your values for tan theta, okay? For theta, sorry. This one here, we okay with that? Okay, this one here, again, before I stop this video, I just wanted to remind you of what we do here. Let's get rid of that. We've got 3 sine theta is equal to 2 cos theta. Can I remind you of what you do when you get to see sines and coses in an equation? In most cases, and I'll go to something what you can't do on the next, something that you mustn't do on the next video, but in most cases you would divide through by cos theta, okay? Only do it when it creates a tan. I'll explain more later, but in this case it does. And I want to remind you of that identity, that tan theta that we looked at is equal to sine theta divided by cos theta. That is why we divide through by cos theta, because when we divide through by cos theta, we get a sine theta divided by cos theta is tan theta, so that becomes a 3 tan theta, and 2 cos theta divided by cos theta cancels out, just becomes 1, so we get 2. So then we divide by 3 both sides, don't we, to get tan theta is equal to 2/3, okay? And when we inverse, it's a positive, so it's in the 2 regions for tan, that actually gives us 33.7 degrees on the calculator, okay? And 33.7 degrees on the calculator, there's my little cast wheel again, there it is, 33.7, we want a 33.7 into this region as well, the tan region, because it's positive, okay? So that would give us 213.7. Okay. All right, guys, so there we go. We looked at the transformations, didn't we? We looked at what do we do when we're solving sine of 2 theta is equal to something. What do we do when we're doing, you know, theta plus or minus, you know, 20 degrees. We looked at translations equals something, okay? Reminder of what happens when we have squared theta, or, you know, cos equal to something, okay? Square rooting, and remember the plus or minus, and in all 4 quadrants. And we've looked at a reminder of the identities. When you get a sine and a cos in the same equation, in most cases divide through by cos, gets rid of your cos, turns it into 1, and changes your sine into tan, allows you one single thing to be able to solve. Remember what we're trying to do? When we're solving normal equations, we try to get down to x on its own. When we're solving trig equations, we try to get down to either sine something, cos something, or tan something on their own. Okay, so when we inverse tan it, or inverse cos or inverse sine, okay, we can then put all of our values down. Okay, and that is over and out from me. Thank you.